Yesterday I told you there's 4 different methods solving two equations when you have 2 equations with 2 variables. Yesterday we solved using what method? Graphing. We graphed them, we found the lower bound, upper bound, found the intersection, right? Today we're going to find the intersection by what's called linear combination or linear elimination. Okay? Method used to find an intersection point of 2 lines in the same coordinate plane. Okay? So we're going to define the same information with a different method, just like we talked about the deer. You can kill a deer with a bow, you can kill a deer with a gun. Yesterday we killed it with a bow, now we're going to kill it with a gun. Okay, same answer. We're going to get a point as an answer. Okay, different method. The equations must be lined up with x's and y's under each other in the following form. When we solve, they have to be lined up like this. My x is here, my y is here, and my just blank c's there. A's, b's, and c's, those are all numbers. These are my variables, x's and y's. Okay, cruising right along. My goal is to examine the coefficients of the variables. What is a coefficient? What's a coefficient? The number before the variable. I want to examine the number before the variable, okay, of coefficients of the variables to determine which variable is easier to eliminate by finding the least common multiple of each variable. The coefficients must be opposites. What are opposites? If I have 2, what's the opposite of 2? Negative 2. The coefficients, you want to pick one and make them opposite. That's our goal. Okay, so that when we add them, we can cancel them out. You'll see what I mean here in a second. Now, step-by-step procedure, in case you don't know what you're doing. Okay, you get into a problem, you're like, I have no idea what I'm doing. Okay, you can grab your step-by-step procedure, you can know where to start. Okay, so turn the page. Let's go step-by-step through the first example. Okay, so you know what I'm doing. Whoops, wrong way. Here we go. Step 1, calculate the least common multiple, or the LCM, of the x's, or the coefficients of the x's. What are my 2 numbers, or coefficients, for my x's?
1 and 4.
1 and 4. What's the least common multiple of 1 and 4?
4.
Yes, 4. Now, when you are looking for the least common multiple, in this case, since we want to cancel them out, it's going to be plus or minus 4. Positive or negative 4. Because you could get to negative 4 just as easy as you could get to positive 4 as the least common multiple. Okay? What about my y's? I have 1 and negative 2. What's my least common multiple? 2. Or, and since I need plus and negative, it'd be plus or minus 2. Now, I have to look at these equations, and I have to think to myself, okay, now I've done these for a while, so for me it's a little easier to look at it, and I can see right away, okay, I'd rather do this one than this one. I want to get rid of either the x's or the y's. So I want to either be able to add these 2 together and they cancel each other out, or add these 2 together and they cancel each other out. One or the other. Okay? So I'm just going to go ahead and do it, and so that you can see. I am going to multiply the top equation by 2. Okay? Because when I distribute that 2, I'm going to get 8x plus 2y equals 10. And I'm going to leave my bottom equation alone, because I have x minus 2y equals 8. Now, when I add these together, what happens? How many x's do I have?
2.
8x plus 1x? When I add 2y minus 2y, they cancel out. Do you see how I multiplied that by 2 to make this a positive 2y, so that when I add them together, they're going to cancel out? I did that. That's why I picked 2. I said, hey, the y, least common multiple is 2. I want to make this equal to positive 2 since this one's negative 2. So when I add them, they cancel out. Now, can you solve for x? X is going to be equal to 2. Now, I have my first point. My first part of my point is 2. I need the y still. How do I get y? Casey?
2 into x and then solve it?
Yeah, pick one of the equations and plug in your value that you know. So I'm going to say, okay, 2 minus 2y equals 8. And I'm going to solve for y. Subtract 2. So I have negative 2y equals 6. Divide by negative 2. Y equals negative 3. So my POI, or point of intersection for those two lines, is going to be 2, negative 3. If you were to graph that, do your lower bound, upper bound, you would get 2, negative 3, just like we just got with the algebra. Okay? Have some of you guys done this in Algebra 1 before? Yeah? Alright, we're going to move on. Let's do another one. First step, if you're not sure, watch the step-by-step procedures. You have never done these before. Okay? First thing, find the least common multiple of my x's and y's. 3 and 2. Positive or negative 6. So my x's is going to be, I want to make them equal to positive or negative 6. My y's, positive or negative 12. I want to make one equal to positive 12, one equal to negative 12, one equal to positive 6, or one equal to negative 6. I can do one or the other. Whatever one you want, that's fine. You can pick your x's, you can pick your y's. I'm going to pick the x's, just because we did the y's last time. So I have to make it equal to 1 equal to positive 6, and I have to make 1 equal to negative 6. So if I want to make this one equal positive 6, what do I want to multiply to get positive 6? Positive 2. So I'm going to multiply the whole equation by positive 2. So that's going to give me 6x plus 8y equals 2. Now, what do I have to multiply this equation by to get this to a negative 6? So that when I add them, they cancel each other out. Negative 3. So I have negative 6x minus 9y equals negative 21. Now I can add them together. These are going to cancel. I have negative y equals negative 19. Divided by negative 1, y equals 19. There's one answer for my point of interest. I have my y, my point of intersection.
What?
Y is 19. Right? You with me? Right there.
What I don't understand is why do you have to use common multiple if you don't even use the alpha?
We do. We use 6 right here. We've made them equal to 6 right here.
Oh, so that's what you're aiming for?
Yes.
Yeah.
That's what I'm aiming for.
Okay, I completely understand now.
Okay. Question, Luke?
Oh, wow. Click up here.
Okay. Now, what do I do to find my x?
Plug in the
Take an equation and plug it in. So I'm going to take an equation, I'll do this one. I don't really care which one you use. Okay, so I have 2 times x plus 3 times 19 equals 7. I put the 19 that I just found in for y. Y equals 19. Now find x. 19 times 3, 57. Subtract 57. And then divide by 2. I have negative 60, no, negative 50. Back, divide by 2. Negative 25. So my point of intersection is negative 25, 19. What's that? Should be negative. So that negative divided by positive. Questions? Questions? Okay, let's do some more.
What's your favorite part about school?
Oh God, you think so? Okay, least common multiple of my x's, least common multiple of my y's. X is plus or minus 6, that's what I'm aiming for.
Wow.
Okay, y's plus or minus 9. So in this case, I'm just going to multiply the top one by, if I want to get this plus or minus 6, okay, I want to multiply it by negative 3. This is already positive, so just multiply it by negative 3. So I have negative 6x plus 9y equals negative 18. And then I have 6x minus 9y, 9, add them together. Oh, cancel, cancel. I have 0 equals negative 9. What's the problem with that? That doesn't work. No solution. What kind of system of equations has no solution? What do the lines look like? Parallel lines. Parallel lines. Okay, we're not in parabolas yet. Parallel lines, right? It's an inconsistent system. Same slope, different y-intercepts. We have parallel lines. There's no solution. Okay, so your answer is no solution. If you were to graph these two lines, you get parallel lines. Okay? Do another one. All right. What am I looking for in my x's? What's my least common multiple? Plus or minus 6. Y? Plus or minus 4. Good idea. So I want this to either equal positive negative 6 or this positive negative 4. What would you prefer? Y's or x's? Y's. Why?
It's already okay.
Right. I already have positive 4 here and negative. All I have to do is multiply this by 4. If I use the x's, I got to multiply both equations. This is already positive 4, so if I make this negative 4, I'm good. Right? So go ahead and do that. Multiply by 4. So I have 8x minus 4y equals negative 4. I have 3x plus 4y equals 15. 5x cancels equals negative 11. Oh, adding. Distracted. Thank you. Adding. So we'll plus sign there. Divide by 11. X is negative 1.
Why is it shouldn't be negative?
Please, can I add a subtract that? There we go. Yes.
I'm lost. I don't really know how you're finding those numbers. I don't know how to find that. I
Find
don't
what?
really, I don't really understand that.
6
Plus
and
minus
4.
6 and 4, yeah.
Least common multiple of 3 and 2. What do both of those numbers go into?
Oh, I see now.
Like when you find a least common denominator,
Oh, I see now. I thought
okay,
you were
least common
multiplying
multiple of
them together.
negative 1 and 4 is positive negative 4. Positive negative 6. Least common multiple. What do both of them go into? Does that make sense? Okay.
I get it now.
All right. So once I find that, I want to make both of those equal to whatever I got. So that I did this one for 4 because it's easier. Plus or minus 4 is what I have right here. Okay. Now, I have 1, plug it in. One of your equations. Take your equation, plug in your x. 3 times 1 plus 4y equals 15. So I have 3 plus 4y, 15, subtract 3. 4y equals 12, divide by 4. Y equals 3. So what's my point of intersection? On 3. Okay, I think we have one more. This is pretty easy.
No, we don't.
We have 4.
Oh, we got one more.
No, we don't.
Oh, you need to make sure, I forgot, I didn't want to print one extra page for one problem, so stick this on your page somewhere, where you have room. Yes.
You have to y with another because you compile it to that plug after the first 3 and I got 1. Yeah.
Oh, when you add 2 both sides, what's -1? Oh, yeah, sure. Plus 2. Yeah, this is possible.
Yeah, that's fucking.
Okay, here we go. Now, this gets ugly.
Oh, it's very.
Very ugly. How, I don't want to deal with fractions. Yes, ma'am?
Multiply it all by.
Yes, multiply this by 3, please. What's going to happen? I'm going to get 3 over 1 in here, and they're going to cancel out.
Heck yeah.
3 over 1, get rid of them. Yes. Okay, so I have 5x minus 7y equals 4. The top equation, I have 10x minus 14y equals 8. Much better. Remember when we did that? Spent so much time, you guys hated it? This is why we did it. Now you can do this and make nice, pretty things. Okay, least common multiple of the x's, least common multiple of the y's. Plus or minus 10?
14.
Plus or minus 14? Which one? Doesn't matter. Yes.
Can you multiply the whole top equation by -2?
Yes. So we're going to multiply the whole top equation by -2. Why would you want to do that? To make this -10. Okay? Watch what happens. I have -10x plus 14y equals -8. I'm going to add it to 10x minus 14y equals 8. Add them together. What is going to happen? 0 equals 0.
Solution.
0.
All possible solutions. Since this is true, all possible solutions, what kind of system do I have? Dependent system! Yes, this is a dependent system. It's the same line. Good. This is all possible solutions. That is the last example. Woo! Your homework is right there.
Where?
Oh.